Hello, Algebra 2 Trig students. Obviously, I'm not here today. I'm traveling with the cross-country team to exchange. So I'm going to take you through the lesson via video. And you'll do some independent work or work in pairs, and then you will watch the video and work independently or in pairs throughout the lesson today. So first, I would love for you to open your booklets to page 12. And then when you get your booklet open to page 12, you can just pause this video and have a little think to yourself, which one doesn't belong? And if you can, challenge yourself, give yourself a minute or two and try to find a reason why each one would not belong. So if you didn't pause and you suddenly just see my ideas on which one doesn't belong, they may match yours or you may have said something different. But I'm also going to try to highlight some vocabulary, so please make some notes in your own booklet if this vocabulary doesn't seem familiar, or if you're unsure, then I would go ahead and add some of this to your own booklet. So this first one, it says 4 minus x squared plus x cubed minus 4x. These are all polynomials, by the way. So this is the only polynomial that is not in descending order. So that's a vocabulary word I would love for you to know. So descending order means you start with the highest degree, the highest exponent, then you go to the next highest exponent, the next highest exponent. So we have x to the third power minus x squared minus 4x plus 4. So this would now be in descending order. So that was the only polynomial not in descending order. Letter B. You might have said that was the only polynomial that had a leading coefficient of 2 and not 1. So what do I mean by that? Well, this is my leading term because it is the term with the highest degree. So the leading coefficient there would be 1. This is the term with the highest degree. The leading coefficient there would also be 1. In letter D, x to the fifth is the term with the highest degree, so the leading coefficient there would be 1. So in letter B, 2x to the fourth, that's the highest degree of 4, but the leading coefficient is 2 and not 1. So leading term is the term with the highest degree, and the leading coefficient, the word coefficient, is that number in front of it. You might have said letter C does not belong because it is the only one with a fractional exponent, so that x to the 1/3 power. And when you have a fractional exponent, that means it is not a polynomial. So polynomials must have whole numbers as their exponents on the variables. So this is not a polynomial. So you also could have said it's the only one that is not a polynomial. So not a polynomial. That is false. Letter D, that is the only one that has a constant of 0. So what is a constant? A constant is the number that doesn't have a variable multiplied to it. So here in letter A, the constant is 4, and letter B, the constant is 2, and letter C, the constant is 2, and so therefore in letter D, there was no number, so that way the constant then, you could put a plus 0, we wouldn't do that, but that means you do have a constant of 0. So again, maybe add some notes on your paper so you remember those vocabulary words because we will use them throughout this unit on polynomials. All right, if you do not have this sheet of paper in front of you, then I would pause and ask Mr. Wood for this sheet of paper so you can take some additional notes, as we're just going to summarize and again emphasize some vocabulary that is not in your booklet, but I would like for you to know, and it's a review of probably what you learned a few years ago or last year in Algebra 1. So the first thing we have here is polynomial standard form. Well, when you have a polynomial, you can either write y equals or f of x equals because it is a function. And when you have polynomials in standard form, we usually put them in descending order, and we have our leading coefficient. So that's 7x to the fourth, or it could have been 1, and then I'm just making this up. So here I have a polynomial in standard form. There are no parentheses. I haven't expanded it, and this is standard form. And standard form is usually in descending order, right? So we have the x to the fourth power, then x squared, then x, and then no x at all. Now, what is a term? So this polynomial that I gave you has 4 individual terms. So terms are these individual pieces that are separated by plus and minus signs. So 7x to the fourth is a term, negative 3x squared is a term, positive 2x is a term, and minus 5 is a term. What is the constant? So the constant is the number that is not being multiplied by an x. So the constant is negative 5. What is the leading term? The leading term is the term with the highest exponent. So 7x to the fourth is the leading term. What is the degree? The degree is the highest exponent value of that polynomial function. So the highest exponent is 4, therefore this has a degree of 4. And we'll learn as we progress through this unit what is significant about that degree and what it might tell us graphically. Your x-intercept, so what is your x-intercept? You find your x-intercept when you set that function equal to 0, right? So when your y value is 0, then you will find your x values. In other words, those are the places where the graph will cross the x-axis. So where does the function intersect the x-axis? That's the x-intercept. So you might want to write that here as well. The y-intercept is where it's going to cross the y-axis. And in this case, it will be the constant, right? Because when you input a 0 for x, so I input a 0, 7 times 0 is 0, 3 times 0 is 0, 2 times 0 is 0, so my constant will be my y-intercept. So in this case, I know my y-intercept is 0, negative 5 for that graph. When we graph things, we will also see relative maximums and relative minimums. If I were to graph something down here, it's not relative to that graph above, but I would have a relative maximum. This would be a maximum right here, and this would be a relative minimum right here. It's relative because it's not the ultimate maximum. You can see this graph goes on infinitely, so there is no ultimate maximum. It is not the ultimate minimum. You can see the graph goes down forever, so there is no true minimum, but the relative means relative with points around it. This is the maximum point, and this down here is the minimum point. So we say we have a relative maximum at, this is a y value here, or sorry, a maximum of, so what would this maximum be, the y value, and then we have a minimum of a y value as well. So if I make my x and y axes here, I might say this has a y value of 1, and this has an x value of negative 2. This, we could say, has a y value of negative 3, and we'll say this has an x value of 2. So I have a maximum value. If this is my x-axis and my y-axis. This maximum right here, when I would go to left 2, I would get a maximum value of 1. So I have a maximum value of 1 when I go 2 to the left, so at negative 2. So this is my x coordinate, and the maximum is my y, because maximum means you're going up, or minimum means you're going down. My relative minimum is down here at negative 3. That occurs at the x value of 2. Okay, so now that we've reviewed some vocabulary, you can grab, find a partner, maybe someone you're sitting next to, and grab a set of cards that you're going to match. So find a set of cards, get them from Mr. Wood, and then you're going to spread those cards out on your table, and you are going to match them. One card will be a picture of a graph, the other one will be an equation of a function, and you're going to be creative and try to use any knowledge that you can to pair those up. A few will be a little more straightforward, and then you'll get a little more complicated, so just be creative. What can you do to try to figure out how to pair up the graph with the equation of the function? Okay, now that you have paired them up, I would like for you to check your work. So now I'm going to give you the answers, and then you also on that sheet you can continue to draw and sketch graphs and fill out this information just to work on your vocabulary. What is the degree? What is the leading term? What is a y-intercept? And then identify the maximum and minimum on the graph, and then show where the graph is increasing and decreasing. So go ahead and grab your worksheet and see how you did on these graphs. So this first one, we should have had that letter A was matching with graph D, right? So you should have had letter A was graphing with match, or the function equation A was matching with graph D. So graph D, I would just sketch it on your paper. It looks something like this, like something like that. So what you might have noticed is that the constant was -12. So it intersects the y-axis at -12. That was kind of the giveaway there. What is the degree? The degree is 4. What is the leading term? The leading term is x to the 4th. What is the y-intercept? That was -12. And then it says put a dot on the relative maximum and minimum. So here is my relative maximum. Here are my relative minimums. So relative with respect to the points around them. And then it says shade one color where the graph is increasing. So I'm going to shade green. This is where it's increasing. This is where it's increasing. Increasing from left to right. So we always read from left to right. So I'm walking up a hill from left to right. And then decreasing, we're going down the hill from left to right and down the hill from left to right. So the blue portion is where it's decreasing. The green's where it's increasing. I have points where my maximum and minimum are. So this is a max, relative max. This is a relative min. This is a relative min. So go ahead and try the rest of these, or try the next one on your own. I'll just start you off. So hopefully you got B to match with letter H, and then do the rest on your own, and then check it. Pause now, and then you can check it when you're done. Okay, I didn't do a great sketch. It was a little hard for me to sketch here, but you should have had a degree of 3, leading term of x cubed, y-intercept of 0, 0, because we have, plug in 0, you'd get 0, 0, 0. And then I have maximums, and I have one minimum. My graph is increasing between the green shaded area, and it's decreasing in the blue shaded area. So now you can pause and try the next one on your own. Okay, so you can check here. Is this what you got? You should have matched equation C with graph A, and you should have matched equation D with graph C. Those were linear, so hopefully you were able to get those relatively simply. All right, pause and try the next ones. All right, this again was something that you were familiar with, so hopefully you could recognize that it's a parabola, has a y-intercept of 24, the leading term is -x squared, and the degree is 2. It has a negative leading coefficient, which means it should have opened down, so hopefully you got equation E to match with graph F. You can pause again and try these last two. If you're not sure, you should have gotten equation F to match with graph G, and equation G to match with graph B, which means equation H should have matched with graph E. So try those last 3 on your own, fill everything out, do the little sketch for yourself, and then you can check your work with me if you need to. So here are the answers with the maximums and minimums, decreasing, increasing, the answers to the degree leading term, and your y-intercepts. So try the last one. And here is your last one. So we'll continue to explore. What do you notice about all those that went through the 0, 0, the origin, and maybe you might think they look the same, but their equations are slightly different. So what do you notice is the same about them, different about them, and we'll continue to explore that as we go throughout this unit. So let's go ahead and try to do the cool down. Let's try to do the cool down here. You should be able to do this. It's not a cooldown, it's just well, it's a practice. It is a cooldown, but we'll go ahead and do that now. Try to write an equation for a polynomial with all the features. You want it to be a degree of 5, so how would you do that? Go back and look at your vocabulary. You want the polynomial to have 4 terms, so think of how you could have 4 terms with a degree of 5 and making sure it crosses the vertical axis, or the y-axis is what that means, at y equals 12. So go ahead and try to create a polynomial. You should have a different one than the person you're sitting next to. You could have a different one than me as well. So go ahead and try that. And then go ahead and try number 2 on your own. So go ahead and pause, do that, and then check your work with me momentarily. All right, so how does your polynomial compare to mine? I have 4 terms. You can see here I've highlighted that in my red. So I have 1, 2, 3, 4 terms. Check that. My degree is 5. That's here in yellow. So check that. And it does cross the y-axis at 12 because you can see that here in green. That's my constant term, so check that. Down to number 2, it says identify the approximate input values. So inputs mean your x values of any relative maximum or minimum. So here's a maximum, here's a minimum, here's a maximum, here's a minimum. So I approximated this to be negative 3.1, I approximated this to be negative 1, I approximated that to be 1, and I approximated this to be, I don't know, 4.9, 4.8, negative or positive 5. So those were my approximations of the input values or the x values for number 2. All right, another notice and wonder. Go ahead and pause and determine what do you notice and what do you wonder. All right, for the notice and wonder, you might notice these are all integers, so it says what can happen to integers. So if you look at your integers, when we multiply 7 times 9, you can see we have integers there. What is happening? Well, we're still getting an integer. So when you multiply integers, you will get an integer. When you add integers, 7 plus 9, you get an integer. When you subtract integers, you get an integer. So you might have noticed that all of these involve 7 and 9. You might have noticed that this last one does not produce an integer. So when we divide, we do not get an integer. All 4 operations are used. This was multiplication, this was addition, subtraction, and this is division. But the only one that did not result in an integer when you started with 2 integers was division. And finally, we're going to do a little practice with our polynomials. So you can create a polynomial or create 2 polynomials, switch your paper with your friend if you want to, or you can just work on adding and subtracting the 2 polynomials I'm going to give you and work on multiplying the 2 polynomials I'm going to give you. So up to you. So if we have a polynomial, we take this first polynomial and then we add it. So I could parenthesize it if I wanted to, I don't have to. And I add it to another polynomial. So are those parentheses having any significance here? They're really not in this case because I have a plus sign separating them. So all I'm going to do is really look for my common terms. So here, my 7 to the 5th, I'm going to put it in descending order. That's the highest one. So that's going to go first. Then I'm going to look for my next highest one. Oh, I see here I have x cubed and minus 4x cubed. So if I have 1x cubed and negative 4x cubed, 1 minus 4, I'm going to end up with negative 3x cubed or minus 3x cubed. Then I go to my x squareds. So I have 7x squared plus 6x squared. So I'm adding those coefficients together. So they're both positive, 7 plus 6. That's going to give me a positive 13x squared. And then finally, I have a negative 5 plus 1. Why am I saying negative 5? Remember, you can always just change those minus signs into plus and negative. So negative 5 plus 1, what do I get? Well, I get negative 4. So can I add 2 polynomials together? Yes. Will I always get a polynomial? Yes, I will. So here's my polynomial. So you can practice with 2 other ones if you want. And then finally, we have the multiplication of two polynomials. So if I gave you x plus 1 times x minus 3, some of you might create a box, right? You might do this, x1, x minus 3, or some of you might do double distribution. So either way you want to do that, you could go ahead and expand. So I would get an x squared minus 3x positive x minus 3, which would be x squared minus 2x minus 3. Or here I would have done x squared minus 3x plus x minus 3 to give me x squared minus 2x minus 3. So when I multiplied two polynomials together, did I get a polynomial? Yes, I did. You can create more to see if it's going to be something different, but it's always going to result in a polynomial. And so what are your takeaways? What are your takeaways? Well, these last takeaways for this was that your integers or your polynomials, you can, when you add, subtract, or multiply, so when you add, subtract, or multiply polynomials or integers, you will get a polynomial or an integer. So if you add or subtract or multiply integers, you will get an integer as a result. If you add, subtract, or multiply polynomials, you will get a polynomial as a result. We call these closed. So that means it's closed under addition, subtraction, and multiplication. So when you get that same thing as a result, so integer, when you add them, becomes an integer, subtract them, becomes an integer, multiply them, becomes an integer. We call that closed under. Integers are closed under addition, subtraction, and multiplication. That is also true of polynomials. Polynomials are closed under addition, subtraction, and multiplication. You really don't need to remember that word. You just need to remember that if you add, subtract, or multiply polynomials to each other, you will still get a polynomial. What do you think will happen if we divide polynomials by each other? So we will answer that question at some point in this semester, but it won't be maybe very soon. All right, any other takeaways? You can write them down, going back to all those vocabulary words we use, the degree, what is a polynomial, what is the leading coefficient or leading term, the leading coefficient, what is a constant. So all of those vocabulary words, we talked about polynomials. They have to have whole numbers as their exponents. You can't have fractions. So we talked about lots of things. We have the maximum, the minimum, the increasing, the decreasing. So all of those, I hope you have taken note of. If they don't need to be in the takeaways, hopefully on the worksheets, keep those worksheets for additional help. I hope this helped. I will see you next week. I'll be back on Tuesday. Don't forget about the volume of the box problem. Please go back and do that. Do your homework, check your work, and I'll see you soon. Have a great weekend.